In last class, we got one new thing, that is refractive index. Can you remember that one, refractive index? What is refractive index? Is it written in your copy? Anyone? We gave this, huh? It must be written in your copy. Yeah, it must be written in your copy. This one. Shafkat, is it written in your copy?
Sir, I'm checking, sir.
Yeah,
So we
take
cannot
it
see
and
the screen.
yeah, today you have to take this notes, huh? So when you are joining class, you should take the notes. That will make you more confident. Okay, if you are writing, you can remember that one. So write it again.
Assalamu alaikum, sir.
Wa alaikum salam. In our last class, you got the definition of refractive index. This one. Yeah,
Yes, sir.
Kazi.
It is a dimensionless quantity calculated from the ratio
Salam,
of the
sir.
speed of light.
Sam.
That
Yeah,
one, sir.
continue. Yeah, continue.
Oh,
Yeah.
from the ratio of the speed of light in a vacuum to that in a second medium of greater density.
Yeah. So we discuss details. Why there is refraction? We get refraction because if light goes from one medium to another medium, one transparent medium to another medium, according to the density of the medium, the speed increases or decreases. Like if light is going from air to water, then speed decreases. Then bending of light will be towards the normal. Isn't it? Hello? Is it clear?
Sir, the bending of yeah towards normal, yes.
If light goes from water to air, then bending of light will be away from the normal, right?
Yes,
That means if light goes from water to air, that time speed of light increases. So refractive index, you got the ratio, speed of light in a vacuum and speed of light in the medium is going. The ratio is called refractive index. That one you can also say in another way. Can you see this one?
Sir, we cannot
Yes, sir.
see the screen.
You
But I
can't see?
cannot see the screen.
No one can see the screen?
So I can see.
Who can't see, please check your connection or check your, you can rejoin. You can rejoin, then I think you'll be able to see. Who can't see? Yeah. Adnan, can you see?
Yes, sir. Yes,
Can
sir.
you see the screen?
Sir, can you take it a bit up again, sir?
Why?
Sir, the first definition. Sir,
Why?
I think I have some confusion, sir.
You have some confusion. So where is your confusion?
Sir, I am rejoining again, sir.
Okay, rejoin. Yeah, where is your confusion? Mohammed
Sir, my
Saf?
confusion is, sir, sir, like how the ratio, sir, the speed of light in vacuum, sir, like how it is measured, sir, the speed of light in a vacuum,
That is a standard value.
a standard value.
Yeah, 3 into 10 to the power 8 meter per second. We know that. Any more questions?
No, sir.
Got your answer?
Yes, sir.
Won't you say thank you?
Oh, thank you, sir. Thank you.
You're so ungrateful. Okay, look here. Another definition, huh? Refractive index. We got the definition. You write another definition. Huh? This one. Please write it. Here it's written this. You write refractive index is a measure. Okay. Instead of writing this, you write refractive index. Refractive index is a measure of how much light slows down when it goes into a new medium. Are you done with writing? Hello? Are you done with writing?
No, sir. No, sir.
Finish writing, please. Nubrat, Aisha,
Sir, can I ask a
yes,
question, sir?
sure, sure.
Sir, is a measure of how much light slows down, but sometimes it also uh, increases its speed, right?
Yes, yes.
So why the definition is like that, sir?
Okay, so very good question. I liked it. Always, when we are thinking about refractive index, we are taking the ratio of speed of light and the medium it's going. Like light is going from water to glass, right? Water to glass. Then we are not taking
Yes.
the ratio of speed of light in water and speed of light in glass for refractive index. Rather, we take the refractive index for water, refractive index for glass separately. Is it clear now?
Then,
So,
sir, what happens?
Like we are not finding the ratio, we are finding the value of the
yes,
both
yes.
things.
Just
Oh,
when we are calculating, we are considering only the speed of light in the vacuum. Is it clear now?
okay, sir. Yes,
Okay.
sir, can you
Oh,
explain
and
one more time? Sir, I understood, but sir, one more time, so like the
Sure.
last
sir, it
part,
is a bit
can you explain?
confusing, sir.
Yes.
Yeah, it's confusing, but you think that refractive index is always we are comparing with the speed of light in vacuum and the medium is going, not refractive index of the ratio of two mediums. Is it clear now? We never calculate refractive index when it's going from one medium to another medium, like from glass to water. That time we don't calculate refractive index. We only calculate refractive index
Oh, because of
when
the
it's,
ratio.
yeah, only it's going from vacuum to glass or vacuum to water or vacuum to what?
Oh,
Any
from
medium.
vacuum to
Yeah.
anything,
Yes. Yeah.
we use the
Is it,
refractive index. Okay, sir.
now it's clear? Is it clear now?
Yes, sir. Yes, sir.
Okay.
Yes, sir. But sir, I have a question, sir.
Yeah, tell me please.
Sir, in vacuum, the light travels faster than air, sir.
Actually, in air, the speed of light is same of vacuum. As the density of air is very less, so the change in speed is there in the air is negligible. That's why the speed we are getting in the vacuum, the same speed we are getting in the air. We will use the same value. Is it clear now?
Oh, yes, sir. Now it's clear. So, sir, now and sir, if a light is traveling from a vacuum to air, the ratio will be like, sir,
Same.
one, right, sir?
One. That's
Yeah.
why we are saying n equals 1 there.
Oh. Oh, sir, do you need to copy the symbol and that things also?
I will tell you. You did this definition. If you are done,
Yes, sir.
then tell me. You are done, then I
Yes,
am
Yes,
sir,
sir.
we
going to
did, sir.
say.
Definition. Sir, definition is done, sir.
Okay, very
The
good.
symbol N.
Now you write this. This one you write. This equation you write. N medium in bracket you give. This one you write. Numerically, we can write this way. When you are doing the calculation, that time you do not need to write all these things. You just write n equals c by v. That's okay. But for your understanding, we are giving this. Is it clear now? Because after 1 week you will
Yes, sir.
forget, and who are joining now, they will be confused. I have to go back again and then explain again.
Sir, I have a question. If the question comes like this, sir, what is the ratio between like from a medium to medium? Then we'll write one.
Yeah, there
Okay,
might
sir.
be
Okay,
question
understood.
like that.
Thank you, sir.
In air
Okay, sir.
and vacuum,
Understood.
the ratio is only 1. So if you are done with this formula, I will go to next step. Tell me please, if you are done. So you are done?
Yes, sir. We're done. Sir, do you need to copy that symbol N and vacuum equal to 1?
Not necessary, it's fine. You already understood it. Now you write the heading Snell's law. You write the heading Snell's law.
The ফর্মুলাটা একবার দেখাতে পারবে?
Sir, we will write the definition of Snell's law.
No, only write the heading. I will tell you what you have to write.
Okay, sir.
Yes, sir. দেখছি স্যার।
Okay, done. Now, if you are done with the writing heading, then you write from here. Refractive index can also be defined. From here you write. After writing Snell's law, you write from here.
Oh, after writing things.
Yeah. Did you write Snell's law heading? Yeah, from here you write. Here to here you give. Then when you are writing this, underline here. You will get mostly this formula, okay? Mostly you will get this formula. This formula is very, very important. Mostly you will get this. Give your triple star. And this is very important. When you are going from denser to rarer medium, that time you have to use this formula. So for getting the refractive index for any medium, we are using this formula. That formula is only for speed of light and speed of light in other medium, okay? Speed of light in vacuum and speed of light in medium, other medium. But this formula is for any medium. You are going to water to glass, or glass to water, or glass to glycerin, or air to glass. Any medium you are going, you can use this formula to get the refractive index by getting the values of angle of incidence and angle of refraction. So are you done with writing?
No, sir.
No, sir. We need more time.
Yeah, please write. The way I gave you a triple star and 1 star, you give. Where is Nubrat? Nubrat disconnected. We have another formula to get refractive index other than these two formula. Then that will be another idea for you. Okay. In 3 ways we can calculate refractive index. Done?
Sir,
No, sir.
just
No,
1
sir.
minute, sir.
Please.
Yeah. Please finish writing. Yeah, Rabi. Hello, Rabi. Shimanto, Faiza,
Yes, sir. Yes, sir.
are you writing?
Yes, sir.
Finish writing.
No, sir.
Why you are taking so long? It's very small thing.
Sir, done.
So all of
Sir,
you are
not done,
done.
sir, not done. No, no, sir.
And who is disconnected? Pfizer. Pfizer disconnected. Okay. So if you are done, then we can go to the next. Mohammad Saad, are you done?
No, sir, sir. I just need a few seconds. Sir, I have a question, sir.
Sure.
Sir, why do we need to rearrange it, sir?
Because you know already one thing, that is uh, refractive index of the medium, which one is more denser, that one is greater, isn't it? Hello.
Yes, sir.
and
Yeah.
the refractive index in vacuum, it is 1. So it is not possible, it's not possible that refractive index will be smaller than 1. Refractive index will be always greater than 1. Now
Yes, sir.
if you want to have greater than 1, you are taking the ratio of sine I by sine r, and you are going from denser to rarer medium. Then what will happen? The ratio will become less than 1, isn't it?
Yes, sir. The
Because
denser
we know,
medium,
yeah,
the
if
speed is less.
yeah, you know that is, yeah, away from the normal. If it is away from the normal, then sine r is greater. Then it will be less
Yes.
than 1. That's why we are rearranging it. Is it clear now?
Oh. Yes, sir. Now it's clear, sir.
Satisfied?
Yes, sir. Now satisfied.
Okay, very good. Thank you for your questioning.
Welcome, sir.
Now, this one you'll write. This heading you'll write. Critical angle. Write this. Critical angle. After writing the heading, you first understand the explanation, then you write this. Write the definition. First, you try to understand the explanation. Can you see the diagram? Everyone?
Yes, sir.
Okay, look. Here, the light rays are going from where to where?
Glass to air.
Glass to air. If it is from glass to air, then what happens? If it is from glass to air, then what happens?
Sir, glass to air, sir. Then what happens?
It is bending towards or away from the normal.
Oh, the incident ray, sir, the refracted ray, sir, is bending away, sir.
So the light ray will be bending away from the normal.
Yes, sir.
Be very much
In
clear.
air.
What I am discussing step by step. If you are not, tracking it, then you cannot go to the next step. You will not understand the next
Yes, sir.
step. So everyone be attentive now. Very much attentive. Okay. You keep your microphone mute, and if I say you, then you open it. Huh? Don't make any sound. Look, when from glass to air, we are going from denser to rarer medium. Then it will be away from the normal. Away from the normal. So, for example, your incident ray, you are starting from here. Your incident ray, you are starting from here. And this is I. This is I. Huh? Then it's bending away from the normal. For example, it is away from the normal. For example, it is your R. Okay? Do you agree with this? I is smaller than R here. So if we are making this angle a little bit bigger, for example, we are starting from here. Okay, now keep your microphone on, everyone. Shimanto, Shafkat, everyone, please keep your microphone on now. Now I will ask you that if I make this angle of incidence little bit bigger, then this ray, will it go, won't it go a bit more larger?
Yes, sir.
Won't it? Like then R will
Yeah.
be, if your R is more bigger, then it will go, this ray will go, for example, it will go in this way. Isn't it? So I is increasing, R is also increasing. This is I now. So this way, if you increase more and more the value of I, then your angle of refraction will also become bigger. And at one stage, your angle of refraction will be 90 degree. And that time your refractive ray will go, you see here the line is showing you the contact of air and glass, right? This line. And refracted ray will go through that contact line. Is it clear? Is it clear, everyone? Hello?
Yes, sir.
For one angle of incidence, that one is going to, the refracted ray is going along the contact line, and the refractive angle is 90 degree. That is called, this angle of incidence is called critical angle. Is it clear now? Hello.
Yes, sir.
So critical angle is angle of incidence. This is first thing, that critical angle is angle of incidence, and to be critical angle we must have to go from the light rays, must have to go from denser to rarer medium, and if the angle of refraction is 90 degree, then angle of incidence is called critical angle. If the angle of refraction is 90 degree, then angle of incidence is called critical angle. Now you can ask me. Yeah, now you keep your microphone on and then you can ask me. Everyone.
So 90 degree না থাকলে ওটা কি অ্যাঙ্গেল বলবে?
Okay. If it is not 90 degree, like it is 89 degree, then still it is only angle of incidence. It's not critical angle. Is it clear now?
Sir, if greater than 90 degrees, sir.
Which one is greater than 90 degree? Angle of,
No, sir, in any case, sir.
yeah,
Refraction, sir, refraction.
angle of refraction can never be more than 90 degree. If it is more than that, if the angle of incidence is greater than, we are going to discuss that one later. If the angle of incidence is greater than critical angle, then it will no more refract it. Okay, the ray will return back to the same medium, like it is going from glass and it will return back to glass. That is called total internal reflection. We are going to discuss next.
Sir, understood.
Is it clear now? And that is happening in optical fiber. Okay, the data transfer is happening in optical fiber by total internal reflection. Is it clear now? Hello? Is it clear, everyone?
Sir.
Yes. Any questions
Sir,
you can
can
ask
I-
me. You can ask me
No,
now.
sir, no question, sir.
If you have any questions, you can ask me now. Now, what you have to do, you have to draw this diagram. Yeah, you have 5 minutes left. You wrote the
For 3 minutes left.
3 minutes. Okay, by 3
Yes.
minutes you draw. Quickly draw. Draw whatever I gave. You draw it here. You show my drawing and the notes drawing together. Huh?
Okay, sir. Can I, sir, like if the refracting angle is 90 degree, then the critical angle will be like, then it will be the incidence angle will be critical, no, sir?
Yes, yes, yes.
Okay, sir. Refracting angle. Okay, sir. Understood.
Yeah. So this is one thing. The condition is angle of incidence is critical angle is called critical angle if angle of refraction is 90 degree. So Zawad, you got your point right here. Angle of incidence is called critical angle if angle of refraction
Yes, sir.
is 90 degrees. And you write
Yes, sir.
another thing here, light goes from denser to rarer medium. So critical angle only we get if light goes from denser to rarer medium. We never get critical angle if light goes from rarer to denser medium.
Yes, sir, I know that.
Yeah,
Like
this
this.
one is very important to understand.
Okay, sir.
So let me know if you are done with your drawing. Quickly draw it, please, everyone. Yeah, less than 1 minute, please. So you finish quickly, huh?
Sir, do you need to copy your the angles you have drawn?
Yes, yes, please do it quickly.
So, is it necessary, sir? Then it will be more complicated to understand.
Okay, no problem. If you think it is complicated, then not necessary. Okay, fine. We'll leave it.